This is Math 7, Section 1.5, Introducing Significant Digits. So, first section, Introducing Significant Digits. Let's talk about approximating and finding out how precise things are, and then we will get into the notes. So if you take a look here at the chapter, you see a graduated cylinder. This is exactly like what we use in science. This measures milliliters. So you can kind of see here, not very close, that it is between the 39 line and the 40 line. But if it's between it, we can't say it's 39 milliliters. We also can't say it's 40 milliliters. This is why we did this in science, is we learned that you can estimate one digit. And that's going to tell us how precise the instrument is by how many digits you can estimate. So precise is telling us how, underline this, precise is telling us that we are going to get a consistent measurement each time. So each time you use this graduated cylinder, right, you're going to get a consistent measurement each time. You're going to see that you will get the same amount of significant digits each time. So if it comes up to the line that says 40, and there's also, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this line is 30, just for example. Let's say we have something where the meniscus comes right here. Now you could say, okay, 31, 32, 33, 34, 35, 36, 37. You could say, okay, 37 milliliters. But our instrument is going to give us more precise measurements than that because we can estimate one. And if it's right on the line, I could say it's 0.0. Same as if our meniscus was right here, 31, 32, and it's kind of in between 32 and 33. So I would say 32.5 milliliters. This instrument each time is only going to give us this many significant digits. Just like our ruler, remember if we have 1 and 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections, they're not quite even, but imagine they are, and you measured something that was all the way from over here wherever 0 was, and it came to here. That length would be 1.1, 1.2, 1.3, 1.4. We already have one decimal place just like we do there, but because this instrument has more tick marks, it's going to be a little bit more precise. So we could measure it as 1.40 centimeters. Same as if it came all the way out to here, and it's not 1.4, not 1.5, not quite 1.6, it's a little bit past it. I'd say it's 1.61 centimeters. So each time we can have those two digits. And this is a little introduction of how we introduce significant digits, how we actually measure them. So why does that matter in math? Well, we are going to apply rules to identify significant digits in a given number. And there are many, many rules. Today we're going to focus on a lot of writing these down, okay? So, rule number 1. Rule number 1, write this down. All non-zero digits are significant. Non-zero digits would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are all significant digits, no matter where they are. So for example, if we have 487, there are 1, 2, 3 significant digits. You can write SD. There are 3 SD. If we have, let's say, a decimal of 65.211, even though these are off the decimal place, they're still significant. So 1, 2, 3, 4, 5. 5 significant digits. If you want to underline them as you're counting, that helps me. 1, 2, 3, 4, 5. 1, 2, 3. Those are some examples. Let's do rule 2. Rule 2 is zeros in between non-zero digits are significant. For example, 1006. These two we know are significant because they're non-zero. But these 2 zeros are in between the non-zero digits. Therefore, they are also significant. So here we have 4 significant digits. If we try another one, like with a decimal, so 51,0007, when we know these are significant because they're non-zero, these are sandwiched in between some numbers, so they are also significant. So we have 1, 2, 3, 4, 5, 6 significant digits here. Rule number 3. Trailing zeros in a decimal are significant. What do trailing zeros mean? Trailing, imagine like a trail following something. 2.1 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Those are significant. Kind of imagine like here, the whole reason we put 0 is to show us that it was exactly on. If you saw this long, long, long trail of zeros, you could say whatever instrument used to measure this was very, 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 very accurate. They had a lot of lines on it. Okay? But anything following is significant. So let's have an example of a trailing zero. 21.30. These are significant. This is a trailing. It's after the decimal point. It's a trail after a decimal point. Therefore, it's significant. So here we have 4 significant digits. What about this one? 40.0. We have a 0 here, but there is a decimal place, and there's another 0. Therefore, we have 3 significant digits. Let's try rule number 4. Zeros on the left of the first non-zero digit are not significant. So far all these are significant, but this one is not significant. For example, if we were to write 0.123, so this 0 is not a trail. It doesn't come behind it. It comes before it. Okay? It's like the 0 right in the beginning. It is not significant. It's there to show us where the decimal is. You need to put it, but it's not significant because it doesn't tell us how accurate our instrument was. So that is 3 significant digits. Another example would be 0.000385, okay? Even though we have many zeros and they're after the decimal place, they're not trailing after the numbers. And there's no number up here. If we had a 3 here or something, then that would be significant, but we don't. It's not. No numbers. So between our first numbers, we still have 3 significant digits here. Moving on to the last rule. Rule number 5. Trailing zeros in an integer may or may not be significant due to rounding. So this is where it gets a little bit confusing, okay? Is where we have something like 300, okay? The zeros are after, they're trailing, but there's no decimal point. So let's say that this was rounded from 298. Okay, our number was 298, and we wanted to round it to this, to the nearest 10. If we wanted to round this number to the nearest 10, okay, the tens place is right here. So rounding it to the nearest 10 would tell us that these two are significant. Because this number is not from what we rounded, okay? Our only significant numbers are this 3 and this 0, because we rounded to the 10. It's the tens place. If we had rounded to the ones place, we would have had 3, but we didn't. Here's another 300. This time, we're going to round from 298 to the nearest 100. Okay? Oops, I shouldn't have drawn that line and draw all of them. But, let me redraw that. 300. So to the nearest 100 from 298, you have to round all the way up to here. And this is the hundreds place, so that's the only significant digit here. We have one significant digit. Again, if we had rounded to ones place, then you could have said that all these were rounded, and we would have 3 significant digits. But you would have had to round to the ones place from like 8.1 or something like that. So we're not going to count that. Okay, those are our rules, 5 rules. I'm going to grab another piece of paper and we'll try and practice. We'll try an example, sorry. We'll try an example. So, example 12 tells us, complete the table, list the significant digits for each number, then count the number of significant digits. So let's make a little table. We have number, we have significant digits, and we have number of significant digits. Okay? First number is going to be 0.0401. Number of significant digits, remember these don't count there before. These two count for sure, and then the one in the middle is squished in between, so it's significant. The significant digits are 401, and the number of significant digits are 3. Next one, 3.1208 are significant digits. These for sure. 0 because it's sandwiched, so we have 1, 2, 3, 4, 5. And our significant digits are 3, 1, 2, 0, 8. Next one is 20. So our only significant digit here is going to be 2 because we weren't asked to round to anything. Therefore, if it's just trailing with no decimal, it's just the 2. So our significant digits are 1. Next, 3.56780. These for sure are significant. The 0, yes, because it's trailing after decimal. So 3, 5, 6, 7, 8, and 0 are significant. 1, 2, 3, 4, 5, 6. We also have 70.0. This for sure is significant. This one is significant because it's trailing after the decimal. So since this one is sandwiched between them, it's also significant. So we have 7, 0, and 0, 3 significant digits. Okay, go ahead and try guided practice. 1, 2, 3, and 4. Let's try example 13. Round each integer to the number of significant digits given. A. We are given 4,321. Okay, the fourth significant digit is 1. So since we have 1, 2, 3, 4, and we want 3 significant digits, we're going to have to round this one. And since it's lower than 5, you round down. And so that gives us 4,320. And as you can see, this 0 is not significant, so we have 1, 2, 3 significant digits. B, 872,090. Right now, we have 1, 2, 3, 4, 5 significant digits. The 0 does not count here. There's no decimal to trail it. But we want to get down to 4 significant digits. So we need 1, 2, 3, 4. We need to round to the hundredths place. Since this 9 is greater than 5, we round up, which gives us 872,100. 1, 2, 3, 4 significant digits. See? 869,700 to 2 significant digits. So far we have 1, 2, 3, 4. Remember, these are not trailing after decimal, so they don't count, but we want to round to 2. So we just want to have these 2 places. 9 rounds up, so that ends up giving us 870,000. D tells us 119,800, 145. We want to get to 8 significant digits. So far we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's get to 8. We only have to round 1 up. It's 5, so you round up. 119,800 and 150. And that gives us 1, 2, 3, 4, 5, 6, 7, 8. Didn't count this one, 1, 2, and that was correct for that. Try guided practice. 5, 6, 7, 8, and 9. We're going to do one more example for this lesson, and it is example 14. So example 14, we're going to identify significant digits of a rounded integer with trailing zeros. This is the one that was a little bit tricky. So let's try this together. A says, in this case, the population of Medville is 84,000. And the population of Alberton, and that's Medville, the population of Alberton is 130,000. So both numbers have been rounded to the nearest 1,000. We're going to tell how many significant digits each one has. So they're rounded to the nearest 1,000, which means they're rounded here. Okay? This one, because it was rounded to the 1,000, it's only left with 2 digits. So only these 2 are significant. These are not significant. Remember, the rounding is weird. Since we rounded to the nearest 1,000, that's where we round. So we have 2 significant digits here. In this one, these ones are significant. These ones are not significant. But here we have 1, 2, 3 significant digits. So as you can see, when you round to the same thing, sometimes it's different. Let's try B. In B, it says, in the recent year, there were 140,000 miles of railroad tracks, and 46,900 miles of interstate roads in the U.S. Both numbers have been rounded to the nearest 100. So they've been rounded to this place, which means everything to the left of it is good. So these are significant. These 2 are not significant. These 3 are significant. These 2 are not significant. Therefore, in this one we have 4 significant digits. In this one we have 1, 2, 3 significant digits. Okay? Last one we are going to try is C.